We get a lot of questions coming to our office about the perspective of the Real Science for Kids books. People will ask, are these creationist books? Are they evolutionary-based books? Do they promote intelligent design? And these are really important questions, and many parents ask about the perspective that my books are written from. This can be a difficult question to answer and to explain, because really the books are not written from any one perspective. In fact, I have a completely different view about how to approach science. So what I wanted to do was create a curriculum that was worldview neutral. And what I mean by worldview neutral is a curriculum that allows students to evaluate scientific information from multiple viewpoints. You see, I believe that all of the perspectives are relevant and they're all necessary for interpreting science. And so what I want kids to be exposed to is all the number of different worldviews that are out there for how to interpret scientific data. And this actually tends to boil down into two major camps. The first camp is the camp that I would call the materialist camp, or the camp that really views the world and everything in the world as being made of matter and energy only. And Western science in particular, but science overall is really, sort of settled onto this dominant materialistic paradigm. And there isn't anything wrong with materialism. In fact, materialist views in science have given us a lot of really important information. It's important to study, nature, looking at the physics and chemistry of how things work and how things are made. But science is more than just investigating things at the material level. I believe that science is also about finding out how we should live in the world and what we should do with the knowledge and information that we have about the world around us. And this is where the opinions about how to interpret scientific data are, and what to do with the data that we collect. This is where the opinions differ wildly. And so the non-materialist viewpoint, the folks that are in the non-materialist camp do tend to be creationists. Intelligent design is also separate from creationism, but it also is a non-materialist viewpoint. And what this group is actually trying to investigate is, okay, you have matter and energy, but you have things that matter and energy alone can't explain, like the DNA code, for example. How does a DNA molecule get its code? Or how do you take chemical precursors and how do they become functional protein, from matter and energy or random processes alone? And so these types of questions are actually also very valuable for science. It's important, I think, for scientists to take a step out of sort of the matter and energy only perspective and look at maybe a different view. And so the way that I wanted to approach science, and the way that I've written Real Science for Kids, is to take a step out of all of the paradigms, all of the worldviews as much as I can, and ask the question, can I present sort of the foundations for science, recognizing that these foundations come from mainly a materialistic viewpoint, but can I present the foundations for science and still honor other perspectives? Why is this important? Why should we encourage students to evaluate scientific information from a number of different worldviews? Well, I think when you encourage kids to evaluate a problem from a number of different perspectives, you give them the richest source of insight we can offer in any education. And that is this ability to evaluate opposing models. When you have opposing models, you actually see the problem much more clearly than if you're only looking at it from one perspective. And so this is true in history, it's true in literature, and it's very true in science. Science really is about evaluating and examining different opinions about how scientific data should be interpreted. It's about arguing over what the science means. And this is an important aspect of scientific inquiry. And so if we encourage students to look at science from a number of different viewpoints, we actually equip them to better understand the science that they're learning. For example, a diamond actually has a number of different facets, and if we only look at a diamond from one narrow perspective, or from one facet, we only see one plane of the diamond. But a diamond actually has many facets, and we get a big picture, we get a better picture, a more beautiful picture, and actually a more realistic and accurate picture of a diamond if we're able to see it from its multiple facets. And I believe reality works something like that. That if we allow ourselves to look at reality from a number of different perspectives, that we get a more accurate picture, we get a more realistic picture, and we're actually able to see things that we couldn't see before. What I wanted to do with the Real Science for Kids curriculum is not take on any one dominant paradigm. So, in fact, the Real Science for Kids curriculum isn't a creationist curriculum per se, but it's open to creationism. It's not a Darwinian curriculum or an evolutionary-based curriculum, but it's open for evaluating scientific information from that perspective. And it isn't an intelligent design curriculum per se, but it allows students to look at science through an intelligent design lens, if they so choose. And so what I want to do with Real Science for Kids and with my books is present a foundation for science, chemistry, physics, biology, geology, and astronomy, solid science for students to learn, but I also want to teach them how to think a little bit outside the box, how to explore things from multiple perspectives, because we don't know where the answers are going to come from for tomorrow's problems. And I do believe it's really going to be valuable for the future generation to be able to look at problems from different perspectives. And that's my aim with Real Science for Kids, and that's what I want to present in my books.